Today we're on pages 36 and 37 of our textbook, Lesson 10, the domain and range of a function. The purpose of functions is to convert inputs into outputs. So each function has two sets associated with it. There's the set of inputs and the set of outputs. The domain of a function is the set of all inputs for which the function rule can give an output. When looking at a graph of the continuous function, the domain is the leftmost input to the rightmost. When we're looking at a coordinate graph, an xy, our domain is our x's. The leftmost x to the rightmost x. The range of a function is a set of all outputs for which there is an input that results in them. When we're thinking of range, we want to think lowest to highest y values. Exercise number 1. Consider a function that has as its inputs the months of the year and its outputs the number of days in each month. In this case, the number of days is a function of the month of the year. The number of days depends on what month we're looking at. Assume this function is restricted to non-leap years. Write in roster form, which is simply a listing, the set that represents the function's domain. Well, the domain is our inputs, which is the months of the year. So we would list January, February, March, April, May, June, July, August, September, October, November, and December. And usually roster form is in the form of a set, so let me add our set bracket notation. B, write in roster form the set that represents the range. The range is our output. So those are the days, the number of days, which we have 28, 30, and 31. Exercise number 2. State the range of the function f of n is equal to 2n plus 1 if its domain, is a set 1, 3, 5. Okay, so our domain, the set 1, 3, 5, would be placed in here. This is called a mapping that we have drawn here. And if we put 1 in for n, 2 times 1 is 2 plus 1 is, we do this, 2 times 1 plus 1 is going to give us 3. So 1 maps to 3. 3 is going to map to an input of 3. 2 times 3 is 6, plus 1 is 7. And an input of 5. 2 times 5 is 10, plus 1 is 11. So 5 maps to 11. 3 was in green. 3 maps to 7. And 1 maps to 3. So 1, 3, 5 is our domain. 3, 7, 11 is our range. Exercise 3, the function y equals g of x is completely defined by the graph shown below. Evaluate f of negative 3. And again, I just want to put in a few numbers here. So 2, there's no scale, we're going by ones. 2. All right, so f of negative 3, we are here. Did I miss something? F of negative 3, here we are, is at negative 2. F of 0, input of 0, output is 2. F f of 5, an input of 5 on our graph. We're here at -1 for an output. And f of 6, 6. We have an open circle there, so there is no output. F of 6 does not exist. There is none. That means that this point is not included. Right? An open circle. None. Does not exist. DNE does not exist. Stands for does not exist. State the domain and range of this function using set builder notation, inequality symbol notation, and interval notation. Okay. Domain first is the x's, leftmost to rightmost. So what you want to do is take your fingers, go to the leftmost point, and then the rightmost. I'm going to use the pen for the stylus for the other side. Left to right. So I'm looking at just from here to here. And what's our leftmost x? It's this, which is a -3. And our rightmost x, follow it down to the x, is the 6. So set builder notation is a set of all x's such that x is there's also inequality notation as well, but x is greater than or equal to -3, but less than +6. Inequality symbols, we just take this from above. X is going from -3 to 6. There's no equal to with the 6 because that's an open circle. Interval notation. With interval notation, the order matters. The smaller number must be written first, followed by a comma, then the larger number. So we do -3, -3, (6). Bracket indicates number is included. Well, -3 is included because there's a solid circle there at that point. So that gets a bracket. Parentheses indicates number is not included. It's an open endpoint. So this gets a parenthesis. Now for our range, range is lowest to highest y value. So you want to go lowest portion of the graph, which is here, to highest, which is here. Lowest to highest. Again, use your hands. Low to high. What's the low y value? I'm looking at the y value here, which is a -5. To the highest, which is 4. So that was the set of all y such that y is greater than or equal to -5, but less than 4. And that's the inequality symbol. Let me finish my set notation there. Okay, so -5 less than or equal to y less than 4. And we have to have y for the variable for domain. Interval notation, -5 gets a closed bracket and the +4 then open, because that was an open circle there. Exercise number 4. The function f of x equals x squared minus 2x minus 1 is graphed on the grid below. Which of the following represents the domain and range written in interval notation? Okay, I'd like to cover that up, cover up the options. And for our domain, write this down. It's got to be left to right. The more you write it, the easier you're going to have remembering it. Left to right. Okay, left to right. Oh, wait a minute, we've got arrows here. So that means this keeps going off to the left and off and up to the right. So our domain here, what's way, way, way out to the left is negative infinity, and way out to the right is positive infinity. So our domain is going to label capital D, is going to be negative infinity to positive infinity. Infinities always get parentheses. And then our range, low to high, has to be that order. Low first. Low is here, that's a -4. And high, oh, here we go, but they keep going way up. And keep going up, 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 you're at positive infinity. So our range would be from -4, bracket -4, positive infinity. So this matches choice 3. For most functions defined by an algebraic formula, the domain consists of a set of all real numbers given the concise symbol. This is like a capital R. It didn't print so well. It really looks like a capital R with a double vertical, right? That's real numbers. Set of all real numbers. That symbol there. Sometimes, though, there are restrictions placed on the domain of a function by the structure of its formula. 2 basic restrictions will be illustrated in the next 2 exercises. The function f of x equals 2x plus 1 over x minus 4 has outputs given by the following calculator table. So here we have a table of values. Evaluate f of 1. Okay, f of 1 is equal to an input of 1 gives the output of -1. Evaluate f of 6. F of 6. An input of 6 gives an output of 6.5. Why does the calculator give an error at x equals 4? That's right here. Input of 4 gives an error. Well, what does f of 4 give us? We plug this into our function above. We get 8 plus 1 is 9. Oh, 4 subtract 4 is 0. What's 9 divided by 0? It's undefined. It's not real. That's why. Because f of 4 is undefined. It's not real. We cannot divide by 0. So it gives us an error. Are there any values except x equals 4 that are not in the domain of f? Our only concern is our denominator. So if we're just looking at our denominator, in this case, I can put any number, any real number. If I put 3 or -15, it'll give us a real output. So are there any values except x equals 4? No, there aren't any. Only x equals 4 will produce 0 for a denominator. And dividing by 0, or having 0 for a denominator, is not real. Does not give us a real number. Exercise number 6, which of the following values of x would not be in the domain of the function? What's not in the domain of the function? Well, let's see. First off, we have a square root. So we have y equals the square root of x plus 4. Can we take the square root of a negative number? No. So what is our domain? Our domain, this would have to be greater than or equal to 0, right? We can't find the square root of negative 2. It doesn't exist. So we say that x plus 4 would have to be greater than or equal to 0. Solve this. Subtract 4 from both sides, and x is greater than or equal to negative 4. Our domain would be the set of all x from negative 4 to infinity. This would be our domain. So out of these 4 choices, which one of these choices is not in this interval? And the one that is not in the interval is for x equals negative 8. Cannot take the square root of a negative number. And we are done. Thank you very much for your attention.